Assalamu alaikum. So homogeneous linear differential equation with constant coefficients. So we will learn 4 cases of this type of equation, but in this video we will focus on the case 1 when all roots are not equal. That means you have a differential equation where every roots are unequal. So how can you deal this equation? So let's see. Let's solve this equation. Okay, so we know that we have to write d by dx according to this, then d square by dx square is equal to d square, and we are writing this thing to write this expression in simpler way. Okay, so you can write this operator as d cube, then this operator as d square, then again this operator as d. Okay, then you have to write y here and the terms of d inside the bracket. Okay, then you have to decompose this term in some factors, and if you do this you will have d plus 1, then d plus 2, then d plus 3, and from here you will get d is equal to minus 1, then minus 2, then you will have minus 3, right? Okay, now how you will get the solution? So how you will get the solution? As you have find 3 roots, okay, you have find here 3 roots, minus 1, minus 2 and minus 3. There are 3 roots. So if you want to find the solution of this equation, that means if you want to find the function of what value of y, you will have 3 terms here. Okay, you will have 3 terms here, and also you will have 3 constants, and these constants are called arbitrary constants. Okay, and then you will have e, and then e. Okay, then plug this root here, minus 1, and then write x, then minus 2x, and then plug this root here and write x, and this is your answer. This is the solution. So you have 3 arbitrary constants. We haven't find the values of c1, c2 and c3 yet. We will find this, but first notice one thing. What you have to notice that the number of roots are equal to number of arbitrary constants, right? You will see that you have 3 roots, so number of roots is equal to number of arbitrary constants. That means you have c1, c2 and c3, 3 constants. So remember this. You will need this concept in the next video. Okay, now let's suppose that you have given this equation, and what was y was equal to c1. Okay, let's write this thing: c1 e to the power minus 1x, then c2 e to the power minus 2x, then c3 e to the power minus 3x, right? It was my solution. And when x is equal to 0, for this case, when x is equal to 0, you have y is equal to 1. So c1 e to the power 0 means 1, then c2 e to the power 0 means 1, then c3, x is equal to 0, so e to the power 0 means 1, and the value of y is equal to 1. It's your first equation. Then when x is equal to 2, you have y is equal to 5. Okay, so c1, then e to the power x is equal to 2, right? So minus 2, then c2 e to the power minus 4, then c3 e to the power minus 6 is equal to y is equal to 5. Okay, this is equation 2. And then again x is equal to 6, then y is equal to minus 10. So you have c1 e to the power minus 6, then c2 e to the power minus 12, then c3 e to the power minus 18 is equal to y is equal to minus 10. So see, you have 3 unknowns and you have 3 equations. So you can easily solve this system easily. You can solve this by calculator, or you can solve this thing by any of the method. Okay, so it's your work. You have to find C1, then C2 and C3, and then tell me the answer in the comment section. Okay, so thank you. Let's meet up in the next video.